Hi team, Mr. Rator here, GCSE to A-level bridging course. Okay, maths. So in this section, section 3, we're going to be factorizing quadratic expressions. So again, quite a bit of stuff you've done here at GCSE level. It's just recapping and doing some stuff which might be a bit of extension of GCSE Maths, but will help you at A-level. Okay, the common factor here is the x, so we take the x outside. It's only x that's common, so x is gone from here, so that leaves me with 5 minus x on this side, and that's it there. Now in here, not only have you got x in both here as common, you also got the factor 2, so I'm going to take 2x out, and 2x times what will give me 2x squared, so I'm missing the x here, because 2x times x is 2x squared, and how many 2 is going to 10 is 5, so that will be minus 5. No need to put x there because we've got it outside. Just double check it mentally in your head. Just go 2x times x is 2x squared, so we got that. That's happy with those. And 2x times minus 5 is minus 10x, so that will give me that. Okay, it's always a good practice to just multiply in your head and double check it works. This one, now when we got something 3 terms here, what we do is we introduce 2 brackets next to each other. Now, if it's only x here, they're pretty straightforward to factorize. So we just put an x in each corner. And then in here, these two, what we need to do is, first of all, we look at this number here and call this the product. And this number here is called the sum. So you think of two numbers which would times together to make 6. So you got 1 times 6 and 2 times 3. Okay, and then you got to see which one was sum to 5. Well, this is going to sum to 7, so this is the only possibility. 2 times 3 and 2 plus 3. 2 times 3 is 6 and 2 plus 3 is 5. And they're all positive, so it doesn't really matter which order you put it in. You can put the plus 2 there and positive 3, or if you want, you could put the plus 3 there and plus 2 there. Okay, pretty standard grade 4 or 5 star question there. This is similar. Again, we look for this one, which has got the product. And in this case, it's going to be the sum. Now, the sum is going to be a negative 8. So, and this being positive means it's in here, in these brackets, they're both going to be the same symbol and they're both going to be negative. So, we've got to have a sum of negative numbers. So, first of all, we're going to get 2 brackets, what we said before. Open up 2 brackets. X in each corner. And then let's make 12. So how are we going to make 12? 1 times 12, 2 times 6, 3 times 4. Okay, now this means they're going to be the same symbol and they're both going to be negative, so these are going to be both negatives. And all we need to do is which one will have a summation of minus 8. Well, this is the only possibility. So it's going to be a minus 2 and a minus 6. Again, if you want to, in your head, mentally expand it out, x times x, x squared, minus 6x, minus 2x is going to give me minus 8x, and minus 2 times minus 6 is positive 12. So, happy with that. Okay, let's scroll down, expanding this. Right, no different, very similar. Well, it's a bit different because this time, this is negative. When this is negative, the only way you're going to get that negative is one number is going to be positive and the other one's going to be one's going to be negative, one's going to be positive. So first of all, open up your 2 brackets next to each other, x in each corner. Okay, so now this is going to be 2 different symbols. Instead of, this is still product. Now this one is the sum, but it's more like a difference of 5. I'm going to call this a difference of 5. So the difference between the 2 numbers is going to give me 5. So let's just double check. 1 times 36. Difference there is 35. 2 times 18. 3 goes into it 12 times, so 3 times 12. 4 times 9 is going to give me 36, 5, and then you got 6 times 6 is 36. Now it's going to be a difference, so the difference there is 35, difference there is 16, difference there is 9. Now the difference there is 5, so bingo. Just highlight that first of all. Now the difference there is 5, but we want a difference of minus 5, so we make the big number negative and the smaller number positive. So what you end up with is a plus 4 here and a minus 9 here. Now it doesn't matter which way around you want to put them, it makes no difference to commutative. So if you want to write it as x minus 9 times x plus 4, it's no problem, whichever your preference. And mentally, if you want to just double check it by multiplying that, x times x, x squared, x times 4 is positive 4x, 9 times x is minus 9x, so 4x minus 9x is 5x, minus 5x, and minus 9 times positive 4 is minus 36, so happy days. Okay, now here, what we got here is what's common in both of them is x. Okay, so like we had in the beginning, we just got x in here, and we open the bracket, so we got x outside, so x times x is x squared, and we've got a minus 9 here. So x times x is minus x, minus 9 times x is minus 9x, and that's it, simple. Okay, questions on. We mentioned this, I think it was in section 1. Now you got to be careful here. This one, you think there's nothing there when you're looking at it, there's no common factor here, but actually when we got this is a square number and this is a square number, and what we got here is what we call is difference between two squares. Okay, so what you get here is you end up with, first of all, open the bracket, close the bracket, so there are going to be two brackets times in each other. You put the square root of x squared, which is x, each corner. Square root of 9 is 3. 3 times 3 is 9. And one becomes positive and the other one is negative. Okay, and that's basically it. Now let me just show you why this works out. What we call this is difference in two squares. It's usually written a squared minus b squared, and we tend to write this as a plus b times a minus b. Now what happens here? Why does this work? Let's just have a look at this. This is a very important concept, difference in two squares, especially when we're dealing with surds and other cases. But surds, when we rationalize the denominator, we look at something like this later. So why does this work? A times a, you get a squared. Now a times minus b is minus ab. B times a is positive ab. Always remember to write it in alphabetical order. And b times minus b is minus b squared. Now the crucial thing here, what happens, and this is the reason why I call it difference in two squares, well, the middle term cancels. Okay, they will cancel because minus ab plus ab equals 0. So you end up with the difference between two squares. Minus means the difference, and you got the difference between two square numbers here. Okay, again, it's about spotting it. If you can spot it here. You got x in each corner, and the square root of 144 is 12. One's be a positive, and the other is a negative. And that's about it. Okay, difference in two squares. So question 9. Now again, this is difference between two squares, if you look carefully. So what you got is square root of that is, let's just write this down. Looks really complicated, but actually when we start doing this, it's not too bad. We've got square root of 36 is 6, square root of x to the power 4 is x squared, so we've got 6x squared in each corner. 6 times 6 is 36, x squared times x squared, x to the power 4. The square root of 9 is 3, and square root of x squared is x, so we've got to get 3x in each corner. And simply 1 is positive and 1 is negative. So that's about it. That times that is 36x squared. The middle terms will cancel. 3x times 3x is 9x squared. You could, if you wanted to be a bit more clever, if you wanted to say, no, I'm not agree with that, I want to factorize that further, you could also take a factor of 3 out here and a factor of 3 out there. So you could say 3 could come out of there. So that will give me 2x squared plus x. Actually, you could even take an x out of here too. Okay. Let's do that. Yeah. So what we could do, we take there's a factor of 3x in both of them. So take the 3x out of here. Okay. So that will be 2x. That will be plus 1. Could also take a 3x factor out of here. So that'll give me 2x minus 1. Then 3x times 3x gives me 9x squared. And you got 2x plus 1 and 2x minus 1. So this is actually a better form of completeness. Difference in two squares and taking a common factor of 9x squared out. Now, if you wanted, you could have spotted this right from the beginning. Okay, the easiest way would have been spotting that right from the beginning and saying, okay, I've got a 9x squared common in both of them, so I'm going to take 9x squared out. Then, how many 9x squares onto there? 4x squared. And that will be minus 1 there. And if we did that, I would have saved you all this trouble afterwards and getting 9x squared out. And then you got the difference in two squares there. So that would have been an easier way to do it. Okay, now spotting that easy way to do it, what you should see here, again, you got 2 common in all of them. So what I'm going to do is take a factor of 2 out and write that as 2x squared, plus 4x plus 3. So double that 2x, double that 8x, double that 6. Okay, so you could spot that getting the 2 out. Once you got that, it's then going back to factorizing as we were doing before. Introduce 2 brackets, x in each corner. Now, this is the product. 1 times 3 is 3, and 1 plus 3 is 4. So 1 and 3, and they're all positive, so we can just put positive there, plus there. And that's that factorized. It's much easier to factorize when the coefficient of x squared is 1. Okay, let's look at a couple of these where the coefficient is not. Again, coefficient is not 1 here. So what we can do is, first thing first, we can take the common factor out, which will be 2, highest common factor. And then put the rest in. How many turns to get is 2x squared plus 7x plus 6. So we got, if we double that, we get 4x squared, 14x, and 12. Okay, so we're taking that. However, still we have not got x squared. As the coefficient is not 1, it's 2 this time. So we have to just be a bit clever, or a bit careful here, sorry, should I say. different ways of doing this. One way is simple way is just trying to spot it, and then the other way is it's a bit more difficult. Well, not difficult. It's a bit more standard, but there's a bit of work to do on that, which I'll explain later. But if you can spot this, it's much easier. So looking at this, first of all, how do we make 6 is 1 times 6 or 2 times 3? But in this case, we have to double one of them. Okay, so we have to double one of them to get the 7. So yeah, let's do it the traditional way, the longer way, so you can see what's happening here. So what I'm going to do is I'm just going to do step 1 is 2 times 6. So I do 2 times 6. It's going to give me 12. Okay, so 2 times 6 is going to give me 12. I now need two numbers which will so now I've got 2 times 6 is 12. So let's just I need to replace this by timesing it out to make 5. Okay, so how can I've got the number 12. What I need to do is I need to think of two numbers which were times together to make 12 and add together to make 7. So now further I break down 12, so I can break down 12 as 1 times 12, 2 times 6, 3 times 4. Okay, and I need to see which one will break down to give me plus 7. So this is the only option that I'm left with, is 3 times 4. So what I do is once I multiplied those, I need to break this down into a product of something that was summed to 7. So I'm going to replace 7x with 3 times 4. Okay, so I'm going to get 2x squared here. That's going to be 3x plus 4x plus 6. So what I've done is literally those two terms remain the same on the end, and in the middle, once I multiplied 2 times 6 and got 12, I replaced the middle by two numbers which will times together to get that 12 and add together to make the 7, which is 3 and 4. And it's all positive. Now, what you then do is, because this is where the little trick's going to happen, now you factorize both of these two terms separately, and you should end up with a common factor. So if I factorize this, not should, you will end up with a common factor, and that then is further factorized. So in here, the common factor here, what I'm going to get is x is common in each of this, so I'm going to end up with x, open bracket, I'll end up with 2x there, plus 3, plus, now what's common in these two is the 2, so if I take the 2 out, so I end up with 2x plus 3. And as I was saying, these are the common factors which I'm going to end up with. Okay, so still put that in square brackets with the 2 out. So what I'm going to get is, I'm going to put the 2. Now, I'm going to take this common factor out, which is 2x plus 3. And what I'm left with is, so that's common with these two, so if I take that out, I'm going to be left with x plus 2. Okay, so this is a common factor. I'm going to further factorize it here, so that has come out. I'm left with x plus 2 out. And that is it. This is the factorized version of this will be 2, open bracket, 2x plus 3, and x plus 2. That's fully factorized. Okay, let's have a couple of more practice. If you know what I'm talking about, please carry on. I'll have another couple of goes at this, explaining it, and see if you can catch on in here. Okay, so apologies if you're not understanding it. My explanation probably isn't the greatest, but I'll have another go. Okay, so let's get it in steps how we're going to do this. Now, step 1, I'm going to do 3 times the minus 6. That's going to give me minus 18. Step 2, I'm going to have to break this minus 18 by 2 numbers, okay, which is a product of minus 18 for sum to positive 8. So if I break it down, I've got 1 times 18, 2 times 9. Here it is. That's the one. So I can call that a positive, and that's a negative. Okay, so let's just circle this out. So step 2, I'm trying to find 2 factors of 18, which will times together to give me minus 18, and sum together to give me positive 7. And that it is. So now, step 3 will be to replace that. So step 3 is to replace this with those 2 numbers. Doesn't matter which order, it will factorize. So I'm going to now replace 3, well, I've got x squared, and minus 6 will stay the same, but replace 7x by 9x minus 2x. Because 9x minus 2x is going to end up with 7x. So that's got minus 6. So I haven't done anything other than changing that for that. I haven't changed the question because that is still simplified to be 3x squared plus 7x minus 6. But this is going to help me factorize it further. So what I'm going to do now is I've got 4 expressions, so I'm going to do them in pairs. I'm going to factorize these 2, and then I factorize these 2. And after I factorize it, I should end up with a common factor in both of them, which I can factorize further. If I don't, I've done something wrong. Okay, so I need to go back, double check. So in this first case, I've got a 3 and an x, which is common to these 2 terms. So I'm going to get the 3x out, open bracket. There's going to be 3x times what will give me 3x squared, so x goes there. And 3x times what will give me 9x is going to be 3. So 3x times x is 3x squared. 3x times 3 is 9x. Okay, so what's common in here is a minus 2. So I'm going to take the minus 2 out. Close the bracket. Minus 2 times what will give me minus 2x. Will be just x in here. And minus times what? Well, how many 2's going to 6 is 3. And that's going to be a negative, so that has to be a positive. So let's just double check. Minus 2 times x is minus 2x. Minus 2 times positive 3 is minus 6. So yeah, happy days. Also, what you will realize, as I mentioned before, this factor and this factor are common in this expression. So I'm going to take that out. So that's the step 4, if you want to call it step 4. Take that out, which is x plus 3. If I take that out, common in these 2, what am I left with? I'm left with 3x minus 2. Okay, and that is my fully factorized form. You can double check if you get this. You can, in your head, mentally just go x times 3x is 3x squared. X times minus 2x is minus 2x. 3 times 3x is positive 9x. 9x minus the 2x is 7x. And 3 times minus 2 is minus 6. Happy days. Okay, if you want to pause it, I will go at this and then press play. Otherwise, continue watching. Likewise, same things. I'm going to do the first step, 4 times the 1, which is going to give me 4. Okay, 4 times 1 is going to give me 4. So I've got to think of, so I'm just going 4 is going to give me 4. I'm going to think of 2 numbers which will times together, which will give me 4, and add together, which will give me 4x. So that will be just simply, well, it can't be 1 times 4 because they're going to add together to make 5. So it has to be 2 times 2, which is going to times together to be 4 and add together to be also 4. So I'm going to replace this 4x squared, and we'll replace this one by plus 2x plus 2x and plus 1. Okay, so I've done that. Now what I'm going to do is factorize these two first and then factorize these two. Now what goes into both of these is 2x, so take the 2x which is common to both. 2x times what will give me 2x squared, so that's going to give me 2x, and 2x times what will give me 2x is just the 1. So that's done. So let's just wait. 2x times 2x is 4x squared. 2x times 1 is 2x. Yep. Now there is no common factor in here. Well, there is. Just be careful because sometimes we say there is no 1 and then ignore that. But there is, and the one that is 1. So there's only 1 that's common. When there's nothing else is common, 1 is always common. So take the 1 out. And that leaves it as 2x plus 1. Okay, so 1 times 2x plus 1 is just 2x. So what happens here is we take the 2x plus 1, which is common to both, so factorize it, take that out, so we get 2x plus 1. And what's left is also 2x plus 1. So this is actually the same factor, 2x plus 1 times 2x 1. So we can write this even simpler by writing it as 2x plus 1 squared. That is a square number, a perfect square. We can just write it